Hi guys, so I just wanted to hop on real quick and show you one more word problem that we can tackle using radicals. This is again another word problem that's just going to involve the Pythagorean theorem and triangles, so it will be very similar to your first word problem, only this will actually be slightly easier. There's one less step. So let's take a peek. So just like with our first word problem, and with all word problems that we've tackled this semester, we are going to use our four-step map of labeling our variable, translating English sentences to mathematics, solving using algebra, and answering in English with units. We will also, as I mentioned, be using the Pythagorean theorem during our translation and solving steps, which says that for a right triangle, the sum of the legs, so a squared plus b squared, the sum of each leg squared is equal to the hypotenuse squared. Okay, so you will see that once again during this word problem. Okay, so let's take a look at our new word problem. It says the length of one leg of a triangle is 5 centimeters. The length of the other leg is 12 centimeters. Find the length of the hypotenuse. So with this word problem, you can see it's actually a little bit easier than our first one. We don't have that extra step of having to solve for perimeter, which is really nice. So let's read it 3 times. The first time, of course, we've just read it. Now, the second time, let's go through and sort of highlight important information. So the length of one leg of a triangle is 5 centimeters. That 5 centimeters is important. The length of the other leg is 12 centimeters. That is also important. Find the length of the hypotenuse, and I'm just going to highlight hypotenuse because that's what we're looking for. And now I'm going to read it one last time, and this time I'm really going to zoom in on what the question is asking me. The length of the leg of one triangle is 5 centimeters. The length of the other leg is 12 centimeters. Find the length of the hypotenuse. Okay, so this time I'm looking for the hypotenuse. All right, so step 1, we need to label our variable, our unknown. And like I said in our first video, it's really helpful with these problems to draw a picture. So let's do that. Here's my right triangle, okay? And when you're trying to figure out what you don't know, it's really helpful to label what you do know. Okay, so I have my I have my sides A, B, and C of my right triangle, right? We know we're going to use the Pythagorean theorem, so let's just paint a picture of what that looks like. We know that we don't know side C, but we do know that side A is 5 centimeters and that side B is 12 centimeters, okay? So our unknown here is the length of the hypotenuse. That is what we don't know, right? We've labeled everything that we do know. The first side is 5 centimeters, the length of the second side is 12 centimeters, but we don't know the length of the hypotenuse. So let's use the variable C for our hypotenuse, okay? It's already there. It's part of the Pythagorean theorem anyway. Might as well use it. And that's what our unknown is the hypotenuse. So let's label that C, okay? So now we need to sort of take our English sentences and translate them to mathematics. And again, once again, to do that, we are going to be using the Pythagorean theorem, just like we did the first time, okay? So we know that the Pythagorean theorem says that when you have a right triangle, a squared plus b squared equals c squared, where a is the length of one side, b is the length of the other, a is the length of one leg, b is the length of the other leg, and c is the hypotenuse, okay? So now let's sort of translate that for this particular problem, okay? So a we know is 5 centimeters, so 5 squared. B we know is 12 centimeters, so 12 squared, and that's going to be equal to c squared, all right? So now we've sort of taken that those English sentences and translated them into mathematics. So let's take a peek at that now. Okay guys, so now we can move into the solving phase of our word problem, step 3, right? So as we said on the previous slide, all we did was substitute into our Pythagorean theorem here, a squared plus b squared equals c squared. We knew that a was 5, b was 12, and c was our unknown, so we left it c. So now we are going to solve this algebraically. We have 5 squared plus 12 squared equals c squared. Let's square the 5 and the 12 first. So 5 squared is 25, 12 squared is 144. That leaves us with 25 plus 144 equals c squared. Let's combine the 25 and the 144, which gives us 169 equals c squared. And then what's the inverse operation of squaring something? We take the square root, right, you guys? This is where our radical is going to come in. So let's take the square root of both sides. The square root of 169 is equal to the square root of c squared, which gives us 13 equals C. And remember, we are only concerned with the principal positive root here. So we are only looking at the positive 13 when we solve this. This is our answer, so let's circle it so we don't lose it. And now we can move into step 4, which is answering, of course, in English with units. So let's take a look at that on the next slide. Okay, you guys, so now we can move into step 4 where we answer in English with units, of course. So as we said on the previous slide, we found that the length of C, the length of the hypotenuse, was 13 centimeters. We want to make sure that our units here match what we were given in the problem. So we were given centimeters, so our units and our answers should be centimeters. Always circle your answer so it goes right to, catches your eye right away and catches my eye right away, all right? And we should check our work, guys. You should always check. So remember, a squared plus b squared should equal c squared here. So our a was 5, so 5 squared. Our b was 12. 12 squared should equal our c, which we now said was 13 squared. And of course, 5 squared, I'm going to come up to the top here, you guys, because I ran out of space down there. 5 squared is 25. 12 squared is 144, and 13 squared is 169. Does 25 plus 140 equal 169? It sure does. So we get 169 equals 169. So this answer checks. Okay. So this one was actually a little bit easier than our first word problem that we saw in this unit. And the key to these really, you guys, is making sure that you use the Pythagorean theorem to solve these problems. This is the only type of word problem we're going to see in this chapter on radicals. I will only be giving you problems that involve triangles where you're going to need to use the Pythagorean theorem to solve them, all right? And in this one, we actually got to see where the radical came into play. So please reach out with any questions. I hope you're all doing well. Take care. Bye.